Okay, good afternoon. Yeah, good afternoon. Today we're going to be doing radical expressions. We're going to do 6 examples, and it's a follow-up of what we did in yesterday's class. All right, you feeling good? You ready?
Oh, yeah.
Thank you. Can I have those glasses?
Goals.
Oh, there's no lens in them. Okay, cool. Can I wear them?
Yeah.
Cool. Why are you wearing glasses with no lenses?
I like him.
Okay, that works. Okay, so actually I can't even see it, even though they don't have lenses. Thank you. Nice catch. So here we have the first problem here. I know we did this yesterday, so this will be redundant, but I just want to make sure that we understand it. All right. The rules are we can't have radicals in the denominator, correct?
Correct.
So we need to multiply top and bottom so that there's no radical in the denominator. What do we multiply top and bottom by so that the denominator has a perfect fourth root? Yes?
4 through 27.
4 through 27, right? Let's talk about why. Because if we multiply top and bottom by the fourth root of 27, what will the bottom be? Fourth root of
81.
81. Exactly. Fourth root of 3 times the fourth root of 27 is the fourth root of 81. And why is the fourth root of 81 valuable to us?
It's
Perfect.
quad.
Right, right. Perfect fourth root, right? So we can say that's 3 on the bottom. And now the fourth root of 2 times the fourth root of 27, what's that?
Fourth root of 54.
Fourth root of 54. Fourth root of 54. Fourth root of 54.
So we just want to get we want to have no radical on the denominator, but on the top it's okay.
Right on. We can't have radicals in the denominator.
How are you sure that you can't simplify it anymore?
Right, good idea. Good job. How do we know whether or not we can simplify the fourth root of 54? Well, we ask ourselves, is 54 a perfect fourth root?
I don't know.
Okay, good. Let's make a list. Remember the list that we did yesterday? Let's do it under the S. Okay. Perfect fourth roots under the S. I got one. 1. Okay, what's the next one?
81.
Before that.
16.
2, 2, 2, 2 is 16. 3, 3, 3, 3, 81. So, we can stop there. Right?
So no.
Even 4, 4, 4, 4 is
256.
256. Good job. And so none of these are factors of 54, so we can stop. Okay, so that's good. Let's take that one off. Someone in my last class actually forwarded the clock 20 minutes, messed with my scheduling. And then I was like, oh my god, we're done with the day. And then he's like, oh, Mr. Dude, I changed the time.
Wow, so we could have we just set up left school.
Well, it would be before lunch, yeah.
We have set up.
I was like, oh, please don't do that anymore. It's messing with the schedule of the day. I was like, I told him I wasn't mad though. Because that's the same class that's like taping markers on the ceiling and things like that. They got mischievous streak to them. Like, let's tape markers to the ceiling. And then later, someone was like, why are there markers on the ceiling? And I was like, oh, the students made a gag and I didn't take it off. Anyway. But I wasn't mad at him. His name was, no, just kidding. All right.
Never met him.
Yeah, you have. Yeah.
No, just kidding. I've never met him.
You never met him before? Okay, so you know what I'm talking
I
about.
look him up on Facebook.
I haven't either.
No, just kidding.
Is 25 a perfect? Is 25 a perfect third root?
No.
No. Let's make a list of the perfect third roots, perfect cube roots, starting with 1. What's next?
8. No.
8.
27.
27.
64. 125.
125. They're like these. All with the
125.
When you
number.
multiply each one by the cubed root of 5.
Correct. Multiply the top and bottom by the cube root of 5. Because what we want is a perfect cube in the denominator. Good job. The reason we do this is now on the bottom we will have the cube root of 125. And what we have on the top?
The cube root of 10.
2 times 5, 15. Cube root of 15. Whoa,
Wait, 10.
10. We rise together, we fall together. And this is the cube root of 10 over 5. Okay, questions on that?
So when we get to the number after making the list, then we don't multiply by the cube root of 125. We multiply by the cube root of 5 because 5 is the cube root of 125.
Yes,
Okay.
because we agree that we want the radicals to go away.
Uh-huh.
And the way to get this radical to go away is to ensure that there's a perfect cube under it, because it's the cube root. And since this is the cube root, if we have the cube root of 125, we're happy, because the cube root of 125 simplifies cleanly to 5. So now our denominator is safe, is managed.
Okay.
And then the top turns out to whatever it turns out to be. Cube root of 2 times cube root of 5 is just cube root of 10. Right? So now we're going to try with variables. Right? So if you can flip the page. Take that off. B to the 9. I don't want to sing that song.
Why? I like it.
No, that would be very boozy. So, sorry for our viewers in the Middle East. Okay. Because they're like. And then yeah. Next, does the top simplify?
Yeah.
Yes, it does to what?
6a squared.
6a squared. Does the bottom simplify?
I would think so, but it doesn't.
Right, because you're thinking square root of 9, right? That's what you're referring
So
to.
really,
So the bottom, let's split into factors that are perfect squares. What are factors of b to the 9?
4 and 2.
B
I mean,
to the
no,
fourth
that's
and-
four and
Okay,
three.
yeah, one step before that.
4 and 3.
What's inside?
B8 and
b to the 8 times b. Right, b to the 8 times b. And so let's continue the top, 6a squared. And indeed, the bottom becomes b to the 4th times the
Square root of b.
square root of b.
Weren't you on
Now,
Can
we can't, what?
Wait, what?
Wait,
you get that?
how'd you get that?
Square root of b to the 8th.
B
What times itself is b to the 8th?
4 times 2.
No, you're thinking
wait.
8. You're thinking 8.
We
Right.
multiply by rad b all the time.
Wait, so wait, it'd be b to the 4th. Oh, b to the 4th times b to the 4th is b to the 8th. So okay.
Right. So don't get numbers and exponents confused. That happens a lot. Yes?
Now can you multiply both top and bottom by square root of b?
Right. Multiply top and bottom by the square root of b. Many times people multiply top and bottom here by square root of b to the 9. It's unnecessary. It's too much. The only thing that really is the issue is the square root of b. So we're going to multiply top and bottom square root of b over square root of b. And then rules for multiplying fractions. What would you say? 6a squared, go ahead.
Times rad b.
Rad b over.
B to the 4th. B to the 4th. B to the
b to the fifth.
B to the 6th.
b to the fifth.
Close. B to the 5th. B to the 5th.
Thanks.
It's b to?
Let's talk about why. B to the 4th remains. And now, what is the square root of b times the square root of b?
Oh,
B.
b.
B. So that's b to the 4th times this b. That makes b to the 5th. Questions on that one? You okay?
Yeah.
I know you weren't here yesterday, so we'll
But you did that
follow
one.
up. We'll follow up.
No, it makes sense. It makes sense. I'm just
Okay.
trying to like.
Okay, so ask if you have any questions, all right? But basically, we simplified the square root of b to the 9 into b to the 4th root b. Then we realized that we can't leave radicals in the denominator, so we multiply top and bottom by root b. And root b times itself is just b. And that b times b to the 4th is b to the 5th. Okay, let's try more. Okay, a couple left. Now we're talking third root. We have the third root of x squared over the third root of what?
Y to the
Y to the 5th.
So can you multiply both sides by the square root of y, or top and bottom by the square root of y to the 4th? Or cubed root of y to the 4th?
That's a good guess, because you're trying to get y to the 9th, aren't you?
Yeah.
Right? But you don't, y to the 9th is too big. You can get a perfect cube that's smaller than y to the 9th.
6th.
Y to the 6th, yes, you could do that. Yes?
Oh, I was gonna say multiply top and bottom by cube root of y.
By the cube root of y, yes. Top and bottom by the cube root of
Wait,
y.
why?
Exactly.
No.
No. Okay. Who can explain? Try. Explain why do we multiply? Let me write it first. And go ahead. Why do we multiply top and bottom by the cube root of y?
Okay, since you can't have radical in the denominator, you want to get a perfect cube.
Yeah, I get that.
And so y squared is the cube. Is that the right way to say it? Y to the 6.
The cube root of y
Y
to
to
the
6
6th.
is y squared.
I get
So
it.
why-
Oh, okay.
The reason we do this is that
because
it,
exponents you can just like divide and then.
yeah,
So it's like cube root of y to the 6.
cube root of y to the 6th,
And then we
now
could
we're
find the
happy.
cube, which is 2y. Or
Say
just
it
2.
again. Say it again.
2y.
Cube root of y to the 6th
Cube root of
is
y to the 6 is 2, wait, y. Y is y squared?
yes, you got it.
Okay,
Good
y
job,
squared.
Good job. Patience. You had a hand here?
Yeah, pizza pop from
Are you sure? Talking about this? Oh, it's a previous problem? Okay. So that's cube root of on the top. Now, can we combine these with multiplication?
Yeah.
Yes, aren't they the same root? So we can. So it's the cube root of x squared y all over. I'm going to write it just to be clear. Cube root of y to the 6.
Isn't it y squared?
And indeed,
Oh.
the top remains. And the bottom, the cube root of y to the 6 is y squared. Who can define in their own words what cube root means?
3.
Yes?
What times itself 3 times?
What times itself 3 times? So I'll ask the question. What times itself 3 times is y to the
Y
6.
squared.
Y squared times itself 3 times is y to the 6. Well done. Okay, so let's keep going.
Hold on one
Unless
Are
there's
you-
questions. Yeah, sure. Go ahead.
Are you allowed to put x squared and y, like the cube root of x squared and the cube root of y because there's a cube? Is that what makes them?
Well, they can combine because we're multiplying them.
Okay. So even if it was square root of x squared
No.
and cube root?
No.
No, so it's the cube that.
The cube roots can make them
Like
combine.
that.
Correct. We can multiply this. Good. Okay, now, what's the issue with this problem?
Oh.
Go ahead.
It has to be a perfect cube, right?
What has to be a perfect cube?
4. The bottom number.
The bottom number. Why must we make it a perfect cube?
That's not the problem.
There's
Because
no
you can
radical.
have it.
Is it?
Yeah, it is. 'Cause
Yeah.
you
Is that
can
the
have
same?
it-
Oh yeah, you want to do
Yeah,
that?
it's
What it
not.
previously was the cube root of 3 to the 4.
And it's the same.
That's the same. Are we allowed to split with division?
Yeah.
Yes, we are. I'm glad you asked that. Yes?
Why can't you just multiply by the cube root of 4? Doesn't that become 4?
I'm glad. Let's actually do that. Okay, I'm going to show it to you because it's a mistake that a lot of people make. So let's do it together.
Because I know that like if you multiply square root of 5 times square root of 5, it's 5.
So you're saying right, square root of 5 times itself is 5. But this is cube roots.
Oh, because it's a cube root, then it doesn't work?
Right.
So it'd be cube root of 16.
This would be the cube root of 16, wouldn't it? So, Mr. Bond. If the bottom would be the cube root of 16, can this be simplified? Or is it a perfect cube, I should say?
No.
It's not. It can be simplified, though. It can be. But it won't simplify perfectly.
So do you multiply by the cube root of 2?
Yeah,
Yes.
that's-
Multiply by the cube root of 2.
Can we do the cube root of 16?
Yeah.
Yeah,
Because that's what I did.
yeah. But you know what the cube root of 16 can simplify? So you'll have to do it on the top. You'll have to.
I don't know. I feel like I'd rather simplify it at like do the easier like what makes sense to me and then simplify it at the end.
Okay.
To me that makes more sense.
I feel you. You'll have to multiply by the cube root of 16 on the top here,
Mm-hmm.
and then the top will be cube root of 48, and then that you'd have to just simplify
Okay.
if you want. Yeah. Okay. And so the top becomes the cube root of 6 over the cube root of 8, which is 2. Okay. In other words, what the books do, which I'm not a huge fan of myself, but I'll just tell you what the books do. They're saying this is 2 times 2. But what a cube root requires is 2 times 2 times 2. That's what the cube root requires. So, in other words, this has 1, 2 missing. That's what it is. It says 1, 2 missing. Yeah.
So if you do it like the way I did it,
Yep,
and you multiply this cube root of 4 by the cube root of 16,
right.
and then be the cube root of 64 for the denominator,
Yep.
then what isn't 4 times 4 times 4 64? So wouldn't that simplify to 4?
Yes, it would.
And then how do we
So
get
we
the-
have to cancel. This would be cube root of 48 over 4. Now the cube root of 48 can simplify. What are the factors inside 48 that are perfect cubes?
16.
Yep, 6 times 8, right? So this becomes cube root of 8 times 6 over 4, which is 2 cube root 6 all over 4.
You can cancel.
And then we cancel indeed. 2 and 4 goes away. This is 2 and this is 1. And so we have cube root of 6 all over 2, which was what we originally got as well. So see how it's like you could do it in multiple ways. That's part of the beauty of why I love math, is because there's always going to be one answer no matter which avenue. Kind of like they say that there's multiple ways to the top of the mountain, right? You have a path to the top of the mountain, do you?
I guess.
You do, right?
Yeah.
Aren't you climbing the mountain in your life?
Yes.
Aren't there multiple ways of climbing that mountain?
Yes.
This is the international symbol for, this is exactly what I'm saying, and I'm glad we understand each other, you know? And this is the international symbol for what?
Violin.
Violin.
Violin? Oh
Tiny
no, I was thinking
violin.
money.
Oh, money.
Money is
Tiniest one.
Money is this. Yeah. This is the international symbol for what?
Check.
Check. Yeah, nice. And it's funny, you're sitting at a restaurant in Morocco and you're like, and they're like, ah, yes, I know. What are some more international symbols?
Hi.
Like hitting someone means I'm angry with you.
Or like thumbs
I
up.
have one, but it's not.
Thumbs up is not.
Thumbs
But
up
it's
is
not really
like
appropriate.
bad.
Thumbs up's
Oh,
not.
really?
That's like
Hitchhiking.
One more.
A lot of people do it differently.
yeah.
Right.
It is.
Like in Asia, they're
And
like,
then there's
No,
some
thanks,
different-
what, man?
There's
Like
something for
this.
Germans, but I'm not gonna do it.
There's one in Europe, I forget the country, but like this is terrible, going like this to them. Like if you're driving and they cut you off, you're like,
Like I'm gonna elbow.
just like take that, something, you know. It's interesting.
That's crazy. Like just.
Yeah. So here we go. This is the last problem we'll do.
Yay.
How do we split this? What should go on the top, what should go on the bottom maybe?
Maybe.
Yeah.
Is this
I think the C to the 5th and the D to the 4th are like on the top.
They are officially on the top, right? So I'm
And
gonna
they're
be
over
right
so you
there.
could just split
Yep.
it to the
So that's the
fraction.
4th root of C to the 5th, D to the 4th,
Over 4.
all over 4th root of 81. Okay?
It's already simplified. You can already simplify from here.
Yeah, a lot of it can. Bless your soul all the way to the top of the mountain.
La 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 la.
Give me your check. All right, is C to the 5th the perfect 4th root? No.
D to the 4th.
So I'm gonna split the C. What are we splitting the C to?
Oh,
C.
C to the 4th
Are you ready?
times
C to the 4th of C.
C.
You're splitting the C.
Wait, is that true? CD to the 4th of C?
No one else gets it.
Wait, are you going to do
You
that
know,
in
Joe?
numbers as well?
Sure. Well, actually, here. What's a 4th root of 81?
3.
3. Okay, we're almost done. Now, 4th root of C to the 4 is
C.
C.
D.
Should this be an absolute value?
No.
Yeah.
No.
Yes.
Yes.
It should be.
Because
The even.
even radical with an even exponent resulting in an odd exponent.
Well, same with the D, right? Or no?
Same with the D. So I closed it too soon.
Hello.
I closed it
Very
too
good.
soon. Very good. And what is still inside?
D. I see.
C.
C. Like, yes. A lot of Spanish now. Yes, D, square root of, yes.
C.
All over
3.
3.
This class is international.
Yeah, it really is. I just like made certain people very offended by going like
We
this.
talked about Morocco.
Yeah, yeah.
Got it.
All right, any other questions?
No.
Okay, golf clap yourselves.
I thought golf clap was like 2 fingers.
Oh, 2 fingers?
That's what I thought.
Do it, do it.
Is it
guess
this
so.
or that?
Why would you call
Don't
like
hit
that?
him! I'm just kidding. No one's hitting anyone. Okay, bye. You got it.
Finish or stop capture?
Oh, you're still playing that? This is funny. Stop captures.